Hello everyone. In this video we will start with chapter 7 where we will discuss about moles and Avogadro's number. Before we jump into moles and Avogadro's number, let me ask you a quick questions. If I say 1 dozen of eggs, what does this mean? So this means that we have 12 eggs, right? So 1 dozen of apple, what does this mean? We got 12 apples. So in this case, the dozen represent the 12, right? So in atoms, in chemistry, since the atoms and molecules are very tiny particles and we have plenty of them, we use in another term instead of dozen. Like if you count 12 atoms, that would be like nothing, right? Atoms are extremely small. So we use another number that's called 1 mole. So let me write this one down. It is 1 mole. And how much is 1 mole? It's a pretty big number, 6.02 into 10 to the power 23. So this is how big this number is. So this number is called Avogadro's number, the 6.02. So that is our Avogadro's number. Okay, so the Avogadro's number, so you name it, it can be anything. So let's say I'm gonna say 1 mole of aluminum. So it doesn't matter what's in here, you can fill in anything. You can say 1 mole of people. Then what does that mean? This means we have 6.02 into 10 to the power 23. Do you want to write this number? Try writing this number. It's 602,000,000,000,000,000,000. I give up. It's okay, I'm just making fun. All right, so 6.02 into 10 to the power 23 of aluminum atoms. Because it is an element, aluminum is an element, so elements are made up of atoms. So we got 6.02 into 10 to the power 23 aluminum atoms. So I could say the exact same thing. 1 mole of carbon is gonna be how much? 6.02 into 10 to the power 23 carbon atoms, right? So I could add another thing. So let's say 1 mole of water. Now I'm thirsty, I want to drink some water. All right, so let's say we want to find out how many exactly water molecules present in 1 mole of water. Again, it's the exact same thing. 6.02 into 10 to the power 23. So in this case, this is water, right? So this is a compound. And compounds, for the smallest particle is molecules. So we're gonna get 6.02 into 10 to the power 23 H2O molecules. So it's like H2O, 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 and we have how many? 6.02 into 10 to the power 23 molecules. That's how many we have. So when we say 1 mole of water, that's what we meant. Good. I can say another things. Let's say I want to say 1 mole of let's say 1 mole of glucose. 1 mole of glucose. You know glucose sugar? So 1 mole of glucose. Glucose formula is C6H12O6. So this means this is a compound, right? So we're gonna have 6.02 into 10 to the power 23 molecules of glucose. Good. All right, so let me do a problem for you guys. It's pretty simple. Questions. How many carbon atoms present. So when it say how many exactly, then you have to calculate how many exactly. Present in 5 moles of carbon. So in this case, for each 1 mole, this is our equality terms. 6.02 into 10 to the power 23. So we got 5 moles. So it's gonna be 5 multiplied by 6.02 into 10 to the power 23 carbon atoms, right? So it's gonna be 30.1 into 10 to the power 23, and let's divide by 10. 3.01 10 to the power 24. That's how many carbon atoms we have. So that's our answers. Okay, all right, so this is how many we have in there. Let's do another problem. This time I'm gonna make it a little bit more complicated. So my question for you is, how many moles of carbon atom present in 10 moles of glucose? So glucose is C6H12O6. So this is one molecule. Our glucose is made up of 6 carbon atom, 12 hydrogen atom, and 6 oxygen atom. So how do you do this? So first you have to write the equality term. So each one molecule of C6H12O6 has 6 atoms of carbon. So it's 6, right? 6 atoms of carbon. So you can make a conversion factor from this statement. So now just replace this molecule of as moles. So if we have 1 dozen of C6H12, then we're gonna have 12 multiplied by 6, right? So you can got the idea. So if we have 1 mole of C6H12O6, that's gonna equates to 6 moles of carbon atom. You get it? So for each one we got 6. And how many we need? So given we're 10 moles of glucose, so if we have 10 moles, so it's gonna be 10 multiplied by 6, as simple as that. So it's gonna be 60 moles of carbon atom. That's it, guys. It's pretty simple. Okay, try to do one last problem by yourself. Questions. So this one you should do it at home. So the formula for vitamin C, you guys take vitamin C pill, is C6H8O6. So my question for you guys, how many moles of hydrogen atom present in 5.6 moles of vitamin C? Good. Okay, so if you want to see the answer, pause the video here because I'm gonna do the answer. So the formula is C6H8O6, right? So the equality term would be, for each 1 mole of C6H8O6, so each 1 mole has 8 moles of hydrogen atom. And how many we are trying to find out? 5.6. So it's going to be 8 multiplied by 5.6. So that's going to be how much? 44.8 moles of hydrogen atom. If I ask you exactly how many would that be, then you can do multiply this 44.8 into our Avogadro's number, which is 6.02 into 10 to the power 23 hydrogen atom. So if the question asks exactly how many numbers, like 1, 2, 3 all the way, so you just multiply this number. All right, we're gonna go to molar mass in the next video, so let's stop here.